In the previous class, we have discussed several types of solid state switches and along with a mechanical switch. Apart from that, we have studied what are the relays and what are the solenoid. So in this class, let us study in detail what are the drive systems. Drives are the systems which will give a controlled motion to the output elements. So automatically it will give precise movements to the output element. That is nothing but a drive. Drive means which is driving, which is giving some motion. That is nothing but a drive. And motors with some mechanisms incorporated, and the mechanisms which will produce the motion, that is nothing but a drive. So if you take motors along with a lead screw, that is one of the example for a drive. The lead screw mechanisms will be giving a rotary motion because of which the table rotates. So this is nothing but a drive. There are several types of drives depending upon the power source. Number one, it is an electrical drive which uses electrical power source. Then hydraulic drives which uses hydraulic power source, oil with reservoir. Pneumatic drives which uses pneumatic power supply, it might be a compressed air. And these three drives, we can always choose these three drives on any applications, but depending upon the feasibility, we will be choosing these three. If you are using electrical drive, means it is economical in nature, it is very easy to incorporate, and establishing a relationship between electrical system and electrical devices is almost easier. Then hydraulic drives are somewhat bulky because it will be having an inbuilt pump along with a reservoir, non-return valve, pressure relief valve, like that. The components will be more in case of hydraulic systems. Whenever we require a huge load to be lifted, in that cases we will be using hydraulic drives for highest torque. And pneumatic drives are almost compact in nature, but compared to hydraulics it is compact, whereas the cost of the pneumatic system will be slightly greater than electrical because we are using a compressor. That compressor will be having a separate unit and it will be having a reservoir in order to store compressed air. So these are the limitations of each drives, and depending upon the applications, the drives are chosen. Since it is an electrical actuation system, let us see in detail what is the electrical drives. So here, electrical drives are the drives which are obtained from an electrical power source or a voltage or current. Electrical power supply, because of which it will work. And these are the different drives what we are using. Motors, those are the rotary motions. In the previous class we have studied solenoid which it is a linear electrical actuator, but motor is a rotary electrical actuator. And motor is somewhat compact. Most of the cases there is a rotary motion in mechanical, so motors are always there in any automated system or any industry. Motors are classified based on the power source. There are two types. One is AC motor and another one is DC motor. AC motor will be using an AC power supply. DC motor will be using a DC power supply. DC means direct current, AC means alternating current. So alternating current will be like this. This is AC and this is DC. Alternating current will have two things. One is positive as well as negative. If you take one sine wave of alternating current, it will be having positive as well as negative. If you take DC, there is only one thing, we will get a stabilized output. Compared to AC and DC, AC has a more advantage because whenever we want to transfer current from one place to other place, say for example I want to transfer a current from Sharavati generating station to Mysore, in that cases I cannot have a DC. I need to have an AC. That AC will be having a transmission lines. The transmission lines what you have seen, 12 kV, 33 kV, 440 kV, that transmission lines we will be transferring current from one place to another place. Whereas if the same thing is to be transferred, I need to have a battery storage capacity which is more than 10 to 15 lorries. So that's why DC current is not so flexible to transfer from one place to other place. In your vehicles, 12 volts DC battery, that is a huge thing what you are using. 12 volts, storing 12 volts, you are using a huge battery. Imagine that in kilovolts, Oh, it will go out of the way. So that's why the transferring direct current is somewhat difficult. And which is safer? Most of the times current is not itself is a safer thing. Current is always a danger. But our body will have a resistance to withstand up to 1.5 to 2 volts. So 1.5 to 2 volts, your USB cable, if you touch USB cable, nothing will happen because your body has a voltage resistance for that. 2 volts is safer. But 2 volts DC is safer. AC, you will be having a slight current. And always, AC, domestic current is very dangerous always because the current is coming out from the transformer. What it will, that current will attract you. Whereas the major currents will push you. So if you see in electrical lines, current and all, the people will not died. The people may died because they are falling from that height, but not because of current. That current will push you. But boiler current is very danger. Geyser current is very danger. It will attract you. The current will flow through your body. Your body will be acting like a earthing. So that's why that is somewhat difficult. Every current is difficult. Always have a precaution when you are using DC or AC. But slightly DC is okay compared to AC. But more than 2 voltage, anything is dangerous. You want to convert AC to DC, for that we will be using pulse width modulation technique. Whenever you want to convert alternating current to direct current, there will be a pulse width modulation. The first thing in our projects is you will be having a DC power supply. How you will be having a DC power supply? Initially, it is having a 220 volts. 220 volts is being stepped down to 12 volts using a step down transformer. After that 220 volt AC will be converted to 12 volt AC. After that, we will be having a rectifier. That rectifier will be converting AC to DC. Then after rectification, you will be getting 12 volt AC to 12 volt DC. After that, there is a fluctuation in the current. That fluctuation current will be always there. We will be using a capacitor or a filtering circuit in order to get a stable DC output. This is nothing but a pulse width modulation. In the pulse width modulation, we will be generating AC, we will be generating DC from AC. So this is one of the important concept in your projects. Probably I will take that in next classes. So let us see the construction of motors. What is a motor? A motor is a device which converts electrical energy into mechanical energy. Everybody knows that. Electrical energy is in the form of voltage that will be converted as a torque, rotation. The fan is having a motor. The input of the fan is electrical energy, the output of the fan is rotation, what you are getting a wind. So during the conversion, these two things, there is a electromagnetic induction phenomenon will be there in the fan. And in the fan we are using a induction motor. Single phase induction motor will be using in the fan. Induction motor, again it is an AC motor. So motors, you know the definition of motor is a device which converts electrical energy into mechanical energy. What are the different types of motor? DC motor, AC motor and stepper motor. What is DC motor? DC motor is a motor which uses DC power supply. AC motor is a motor which uses AC power supply. What is a stepper motor? Stepper motor is a DC motor which will rotate in terms of steps, which will rotate in form of pulses, steps. In DC motor you will get a continuous rotation, in AC motor you will get a continuous rotation, whereas in stepper motor you will be getting rotation in form of step angles. Those things are very important. Let us take DC motor in detail. What is this DC motor? Again, a motor which uses DC power supply. Where to get DC power supply? From AC only. How to get from AC? One is you are using a step down transformer, then you are using rectification or rectifier, then after that you are using filter, because of which you are getting a stable DC output. That is a power source for DC motor. Then after that, what is the construction of DC motors? Before going to that, let us recall the Faraday's laws of electromagnetic induction. What are the Faraday's laws of electromagnetic induction? The first law states A change in magnetic field linking with the conductor induces EMF. A change in magnetic field linking with the conductor induces EMF. So, the first law is, if there is a magnetic field, it induces EMF, and magnetic field should be there with the conductor. It should be linked with the conductor. According to this law, whenever there is a magnetic field, whenever there is a conductor, both the things incorporated and you will get electromagnetic force. Electromagnetic force is F, that is nothing but NBIL. So if it is a AC, you will get cos theta. It is not AC, just NBIL, that's all. So, where N is number of conductors, how many conductors we are using? B is magnetic field generated, I is current, and L is length of conductor. So, this is the first law of Faraday's. Second law of Faraday's is the induced EMF is directly proportional to rate of change of magnetic field linking with the conductor. How much EMF induced? That is directly proportional to rate of change of magnetic field linking with the conductor. By these two things, the motors are designed. Basically, the motors are designed based on the Faraday's laws. First, what I need to do? First, I need to create a magnetic field. How to create a magnetic field? The answer is answer is magnet. I am using north and south poles. These poles are causing magnetic field. These poles are causing magnetic field, and these two are magnets. They are permanent magnets. See here, there are magnetic lines of forces. And what is this armature? It is a conductor. This is a conductor. When I introduce a conductor in between magnets, already there is a magnetic field. Because of this conductor with a current, what happens? The electric field will be generated. This electric field will be moving like this. Because of collision of magnetic and electric field, there will be a torque generated in the armature, which tends to move the armature in this direction. This is a first movement and this is a movement. This will cause rotation. So this is a principle of DC motor. Whenever you want to actuate a motor, there should be a magnetic field and there should be a electric field. The magnetic field you are getting because of magnets, electric field you are getting because of conductor which is energized or which is having a potential differences. So this is a concept of motor, electromagnetic induction in motors. Let us see the construction of DC motor. When I say a DC motor, the simple DC motor available is brush type DC motor. There is another one, that is brushless type DC motor. What is this brush type? The brushes are provided on the conductors. Whenever there is a rotation, the brushes will be in contact with the armature. Because of which what happens? The wear and tear of brushes will be there. So this is one of the limitation in DC motor. That's why the cost is very less. So this is a construction of DC motor. Again I said two things. One is you need to have a magnetic field, another one is you need to have an electric field. Where to have a magnetic field? Here there are two things. One is stator and another one is rotor. Here the rotor is a conductor or an armature, we will call it as. That will be rotating. Rotor means it will rotate. Stator means it is a stationary. Again I said we need to have a magnetic field, we need to have an electric field. Where to have a magnetic field? Here the magnetic fields are located in the stators. So the stator will be having a poles. What are the poles? What are the poles of the magnet? North and south. If it is not, this is south, north, south. Those are the poles. Then a rotor is having a conductor. In other words, the stator will be having a magnetic field, the rotor will be having an electric field. Whenever you energize this, what happens? Because of magnetic field, because of electric field, because of their collision, the torque will be generated. This torque will be rotating this motor, because of which you will get a smooth rotation. How to get more smooth rotation? increase the field poles. This is a north, this is a south. Whenever you energize this, the polarity will be changing because of intensity of electric and magnetic field. So electric field and magnetic field both are causing a torque or a current. Because of these two, current will be generated. This current will be generating a torque. The torque will be moving with respect to poles. If this is a north, this is a south, when you energize this, this becomes south and this becomes north, and this motor will be try to match with a polarity. So that will go to north. If this is a north, it will go like this. If this is a north, it will go like this. If this is a north, it will be go like this. Like this, you will get continuous rotation of a motor. This is nothing but a DC motor. Why the name permanent magnet? Permanent magnet is there is a magnet in the stator which is permanently situated, which is not rotating. This is a construction of DC motor. While writing, first write what is a stator, then write what is a rotor. Stator is having a magnetic field, rotor will be having an electric field. Stator will be having a field poles, rotor will be having a conductors. And some of the cases, very important thing is, whenever you write a DC motor, the number of poles should be less than number of conductors. Because those conductors will be carrying the current and these poles will be carrying a magnetic field. That is very important. And whenever we decide a magnetic flux density B, whenever you want to decide the value of B, in that the design itself, the pole coils or field coils must be less than a conductors. Otherwise what happens? More magnetic field, less current. Because of this what happens? More magnetic field, less electric field. And again the magnetic influence will be there, and the motor, irrespective of the current, it will start rotating. Two things, you have to increase magnetic field, either you have to increase electric field. When you want to make those two are neutrals, this is a condition. And always there is a increase in magnetic field. Because of this armature will tries to rotate in reverse direction. So this is called as back EMF. Because of larger back EMF, this armature will be trying to rotate in reverse direction. This is always there in case of DC motors. So that is one of the limitations. Because there will be a high magnetic field, because of which armature is also having some inertia. Initially we need high torque, after that the torque should be neutral so that it will rotate in correct position or in correct way. This is how we are getting a continuous rotation because of an electrical energy. This is a concept of permanent magnet DC motor. Sir, can I stop this? Yes, you can stop, but you have to switch off the motor. That is the thing. In DC motor, that we cannot stop. In permanent magnet DC motor, we cannot stop motor anywhere. If you want to stop the motor, we need to stop the system itself. That means there is no flexibility for intermediate angles in DC motor. It will rotate at 360 degree. Sir, can I rotate the motor in other direction? Yes. How to make this? You change the polarity. If you change the polarity, then north becomes south, south becomes north. Because of this, it will be rotating in other direction. So very important thing, when you want to rotate a DC motor in other direction, you must change the polarity. That polarity will be changing the magnetic field in the circuit. Let us see what is the basic circuit incorporated in DC motor. It will be having a resistance, it will be having an inductance, and this is an armature. Because of this armature, already I said there will be a back EMF. This back EMF will be tries to move the motor in opposite direction. If I apply Kirchhoff's voltage law here, the total voltage in the circuit will be equal to sum of the individual voltage across the elements. So total voltage will be VI. VI will be equal to voltage across resistance, voltage across inductance, and voltage across back EMF. So this is a current loop. we will call it as I. And if you substitute using a Ohm's law, V is equal to Ri, this is resistance into current, and this is voltage across inductance L into di by dt, and then this is a back EMF. Back EMF is directly proportional to the rotation, angular velocity of the motor, so Kb into d theta by dt. So if I neglect the inductance, if I neglect this, this will be equal to 0, and this is the equation what I have got. And this equation, what it will be doing is, this is proportional to current as well as back EMF. If there is no back EMF, then whatever the voltage generated in the DC motor is directly proportional to the armature current in the armature. Also, if I use a mechanical system, there is a mechanical system here. How the mechanical system? The torque is directly proportional to current. The torque is directly proportional to current. If you take the proportionality constant outside, you will get torque is equal to Kt into I, where Kt is the constant of proportionality, which is called as torque constant. So this is the equation for the torque. So here the torque is proportional to voltage. Whenever you want to control a torque, control the current. How to control the current? Control the voltage. So these things will be there in DC motor. Initially, whenever I want to start a DC motor, the DC motor should be having a high torque. Initially it should have high torque. Why it should be having high torque means to overcome the inertia, because there are several components in the DC motor like armature, conductors, everything, and the weight of armature, weight of conductor, we need to overcome those things. It is just like I need to start a vehicle. Why only first gear? Can I start in fourth gear? No, because first gear will be having a maximum torque. We need maximum torque to overcome the maximum inertia of the vehicle. Otherwise what happens? Just if you push the vehicle without starting, it will be huge because there are many components. When you start and move, it is very easy because initially there will be a high torque. That high torque will be overcoming all the inertia forces inside the vehicle. This is a concept of the same thing applicable in case of DC motor. Here first we need to have high torque. After that the torque should be low, because torque means just a rotation. It is a force into rotating distance. After that I need more speed. It should rotate continuously. Initially I need more torque to overcome more inertia. After that it will be stabilized and I want high speeds later. So this is the lines of different values of voltage. This is one different voltage. Voltage will be constant. Say for example voltage is 2 volts. This is 5 volts, like that 10. First gear will be having highest torque. Second gear will be having comparatively low. Fourth gear will be having very low torque. Same concept in case of DC motor also. And this is about permanent magnet DC motor. Some of the cases, what are the advantages here? The advantages is constructions are simple and it is cost effective, and you can generate high torque. Various DC motors will be available starting from 8 volts, 12 volts, 24 volts, etc., etc., etc. And some of the cases in your board, say for example microprocessor board, the voltage will be 5. But you want to operate 12 volt motor. How will you operate? The answer for that is you have to use a H bridge circuit. H bridge circuit will be having diodes which is placed in the H position, so that the total circuit will be acting like a rectifier. So that will be having flexibility to operate 12 volts or 24 DC motor, but the power source in the microprocessor is 5 volts. So your basically microprocessor will be having very less voltage, that is 5 volts, and you want to operate 12 volt motor. For that you need to have a bridge rectifier, that is called as H bridge. There are several modules available, LM293D, LM298, those things will be using in interference with the motor. So limitations of this is, whenever you want to stop a DC motor, it is very difficult to stop. You have to switch off it. You cannot stop this at intermediate position. Second thing is, since we are using brush The brush motors will be what happening? It will be causing wear and tear for the conductor always. We need to replace the brush, otherwise what happens is the stator poles may get damaged. And whenever you want to reverse a polarity, you want to reverse the direction of the motor, you need to reverse the polarity. So these are some of the limitations of DC motor. And if we use more magnets will leads to more magnetic field. More magnetic field leads to more back EMF, because of which the field poles or magnet poles will be less than the conductors which will be using. So this will cause more inertia because of high magnetic field. That is one of the limitation of permanent magnet DC motor. What they have done is, in order to overcome this effect, they have used non-permanent magnet DC motor. That means the DC motor is excited based on the coils. I will be writing that circuit after this. So this is about permanent magnet DC motor. So let us see non-permanent magnet DC motors, or in other words it is also called as DC motor with field coils. DC motor with field coils. So there are two types of excitations. What we are doing is, one is for armature and another one is field coil. This field coil will be added to the armature in order to maintain the impedance of the motor. Some of the times what happens, due to high magnetic field, electric field will not be balanced. In some of the cases there will be a larger electric field, but magnetic field will not be balanced. But in DC motor there is only one case where there will be a large amount of magnetic field, because of which what happens, the imbalance will be created in the motor. Because of this imbalance, the armature tries to rotate in reverse direction. That is nothing but it generates a back EMF. This is one of the limitation in case of a permanent magnet DC motor due to increase of large magnetic field. Let us see non-permanent magnet DC motor. So when in the exam if they ask, explain non-permanent magnet DC motor or explain DC motor with field coils, both the things are same. Here there are four cases. One is series wound DC motor, second one is parallel or shunt wound DC motor, number 3 is compound motor, and last one is separately excited DC motor. Let us take one by one. The first case is series wound DC motor. The name itself indicates series. The series means the field coil is connected in series with the armature coil. There are two parts again. One is armature coil and another one is field coil. Here in series wound DC motor, the field coil is connected in series with armature coil. That means both are in series. If I want to actuate the motor, armature coil should be high as well as field coil should be high. That means the excitation must be there for the both armature as well as field coil. If one of the excitation is not there, then the motor will not work. So this is the series wound DC motor. What is the advantage of this? The advantage of this is, since those two are connected in series, we can have higher voltage. Higher voltage leads to higher current, and higher current leads to highest starting torque. Because of highest starting torque, we can overcome the inertia easily and the motor will be having a smooth rotation initially. After that what happens? Again highest torque will be continued because there is no continuation. Whenever you give excitation for the armature coil voltage increases. Whenever you give excitation for field coil resistance increases. Combined resistance will be increases in case of this, because of which the voltage will also increases, because of which torque will be also increasing. Whenever you want to write a circuit diagram, first you have to see the heading series. If it is a series, please connect these two in series. Then importantly, next thing is you have to write torque speed characteristics. In torque speed characteristics, it will be having a highest torque and later which the speed goes on decreasing. That means if the system is having highest torque, it will be having low speed. If the speed is high, the torque will be low, because those two are inversely proportional to each other. Because of which we are getting highest torque, but we are not getting no load speed. That means the speed of the motor might be less, but there will be a torque. This is not a desired case. I want torque at initially because to overcome the inertia. After that I want rotation, I want speed. That means here there is no load, there is no less speed and no load speed will be there. Sorry, greatest no load speed will be there. What is this greatest no load speed? That means if motor is not being loaded, if motor is not lifting something, if it is not rotating something, in that cases it will be having a no load speed, highest no load speed. If you have a load, ultimately what happens? The speed goes on decreases. So there is no constant speed regulation in case of series wound DC motor. This is one of the limitation. Next, let us see shunt wound DC motor. Shunt wound DC motor. Here what we will do is, here we will be connecting field coil parallel to the armature coil. Because of that parallel, we can apply separate voltage for the field coil, we can apply separate voltage for armature coil. So because of which flexibility, what happens? One of the coil is excited, the motor will be switched on. In this case, what happens? Since there are two coils, only one is being actuated and other is partially actuated, or sometimes it might be reverse of that. Because of this, you are getting a low torque. The torque will be low, but you have a good speed regulation because of these two motors, these two field coils. This motor has a good speed regulation because of these two coils. This is one of the advantage in case of shunt wound DC motor. The advantage here is we are getting good speed regulation, but no torque. Here the advantage is we are getting highest starting torque, but no speed regulation. The motor speed maybe varies. So what happens in some of the cases, most of the cases, we need highest starting torque as well as a good speed regulation or a constant speed. If I choose a motor of 50 RPM, it should rotate at 50 RPM only. It should not fluctuate. If I use series wound DC motor, the speed will fluctuate. So what we will do is, we will combine the series as well as parallel combinations or the features. So that combination is called as compound motor. It is a combination of series as well as shunt wound DC motor. Here there are two field coils. One field coil is in series with the armature and other field coil is in parallel with the armature. Because of this series nature, you are getting highest torque. Because of this parallel, you are getting good speed regulation. Both the features are combined to get this. Here you will be getting both the things. This is more advantage, but the construction cost is costly. Why? Means you are using two field coils. Controlling of two field coils is somewhat important here. We need to take correctly what is the impedance of this. Otherwise what happens? It will affect the characteristics. And see here, this is a graph. Highest torque as well as good speed regulation will be obtained in this compound wound DC motor. The final one is separately excited DC motor. The name itself indicates separately excited. You are exciting armature coil, you are exciting field coil. When you excite armature coil, it is called as armature controlled DC motor. When you excite field coil, it is called as field controlled DC motor. Whenever you want to lift higher load, then you excite field coil. Use field controlled DC motor. When you want to lift a small load or medium load, you excite armature coil. So it is armature controlled DC motor. Based on the excitation, the control of DC motor will be changing. And this separately excited DC motor is a special case of shunt wound DC motor. In other words, we are making a separate connection. And here there is a difference is, the difference between shunt and separately excited is, when you are exciting a armature coil, when you are using armature controlled DC motor, what you are basically doing is, you are controlling the speed of DC motor using armature supply voltage, but the field supply voltage remains constant. It is not in off condition, it remains constant condition. If you are using field control DC motor, you are exciting field coil here. Here, the speed of the DC motor is controlled using field supply voltage, but armature supply voltage remains constant. And this thing you have to remember here. This excitation flexibility will be there in separately excited DC motor. Most of the cases, we are using separately excited DC motors. And this is one of the optimal, economical, and easiest thing in series. When you want to change the polarity, it is also easy to change. So this is about non-permanent magnet DC motor. Sometimes what we will be expecting is you need to write the characteristics or a graph in a combined fashion. You have to compare series, compound and shunt. So this is a combined characteristics, torque speed characteristics of the DC motor. So this is combined graph, this is individual graph, anything you can write. The same thing here, higher starting torque, here good speed regulation, here the combination, and here there is a flexibility because compound motor will be having bulky because of two field coils. Here there is only one field coil, one armature, you can excite anytime, that flexibility will be there. This is about non-permanent magnet DC motor. Why it is called non-permanent magnet DC motor is you are using armature and you are exciting only the field coil, that's why. This is about DC motor with field coils or non-permanent magnet DC motor. The next important concept of DC motor is speed control in DC motor. How to control the speed, how to regulate the speed. Here there are two things, one is voltage and current. The answer for speed control of DC motor is pulse width modulation. How you are controlling speed of DC motor? By using pulse width modulation. I have a 50 RPM motor. Just 25 RPM is sufficient for me. How to use only 25 RPM? The answer is pulse width modulation. So what it will be having is, it will be having a rectifier. This rectifier will be controlling the pulse. Basically the pulse will be controlling. The width of the pulse is controlled. So this is a stable DC and this is pulse width modulation. These two steps will be done using a rectifier and a diode. And here this is 100% you are using, 100% output you are using. That is nothing but if you are using all, it is 100% duty cycle. You are using 50 RPM here, 80%, 50 into 8, you are using 40 RPM. So 80% duty cycle. You can use a DC like an analog signal. That is one of the advantage of pulse width modulation. You can vary the brightness of the light, you can vary the speed of the DC motor here. This is very important. You can run a 50 RPM DC motor in a 10 RPM, 20 RPM, 30 RPM, etc. So these are nothing but a duty cycles. If you are using utilizing full output, it is 100% duty cycle. If you are using half, it is 50% duty cycle. Depending upon the RPM, you can change the duty cycles. So the width will be changing. This is 100%, it will be having more width. 80% comparatively less, then it will goes on reducing. This concept is very important in case of speed control of DC motor. Here there are two things. If you want to control the speed, control the voltage. If you want to control the torque, control the current. If you want to control the speed, control the voltage regulation. If you want to control the torque, control the current. That is one of the concept in speed of DC motor. Some of the cases you can interface a hedge bridge in order to increase the voltages. That is also possible. And most of the cases, the DC motor is having flexible in even a microprocessor also. In a microprocessor, there are several DC inputs. One of the input is pulse width modulation input. If you use a PWM switch in microprocessor, then this have a flexibility to vary the voltages. If you vary the voltage, then the speed will be varied. Basically 80% means you are using only 80% of the voltage. You are getting 80% of the speed. This is the concept of pulse width modulation or speed control in DC motor. Next, since we are using brush type, in brush type there is a commutator and a brush. Because of the contact of brush with commutator, you need to change the brush frequently. Since there is a contact, sliding contact, what happens? The friction will be generated. Because of friction, more heat will be generated. Because of heat, wear and tear of the part will be taking place, and this brush will get overknown. Because of this, what happens? There is a continuous replacement of brushes will be essential in case of DC motor. So, in order to avoid that, we are using brushless DC motor. In brushless DC motor, what we will do? Basically, we will do ulta. The rotor is replaced with the permanent magnet and stator is replaced as conductor. Whereas in brush type, what happens? The rotor is a conductor, the stator is a permanent magnet. Here it is reverse. We made a permanent magnet rotor and a stator as a conductor. Everything remains same, because since the rotor is having a permanent magnet, the rotor is having only two, north and south. Because of this, the rotor poles will be less compared to stator poles, and no magnetic field will be generated more, and back EMF will be comparatively less in brushless type DC motor compared to brush type DC motor. Here, since we have used magnet here, there is no magnetic field much generated, but here electric field will be more compared to magnetic field. That electric field you can control using a resistor. If you put a resistor, the electric field will get balanced and you will get a smooth rotation of a motor, and it is a maintenance free. You have all these advantages. Ultimately, the cost will be more compared to brush type DC motor. The cost of brushless DC motor will be more compared to brush type DC motor. And this is about DC motor. We started with drives, we started electrical drives, we started what is a motor. In the motor, we have taken DC motor. The DC motor, two things, one is brush type and brushless type. In brush type DC motor, permanent magnet DC motor and non-permanent magnet DC motor. In non-permanent magnet DC motor, series, shunt, compound, separately excited, and also the concept we have read is speed control of DC motor, and what are brushless DC motor and what are the advantages of brushless over brush type. Thank you.